Hello, in this video we're going to do a monopolistic competition math problem. In a city, the market for lawn cutting service is characterized by monopolistic competition. Each firm faces the following inverse demand for lawn cutting. Price equals 1,000 divided by n minus 10q. P is the price per lawn cut, Q is the number of lawns cut per day, and n represents the number of lawn cutting firms. MR is the marginal revenue, which would technically be the derivative of total revenue with respect to Q. Here's the total cost of lawn cutting, and the marginal cost is just a derivative of the total cost function with respect to Q. Average total cost is total cost divided by quantity, so 200 divided by Q. 2.5q squared divided by q leaves us with 2.5q. We want to maximize profit, so we want to find where marginal revenue equals marginal cost. So setting our marginal revenue equation from the last slide equal to marginal cost, we're going to solve for q. So adding 20q to both sides, we get 25q equals 1,000 divided by n, and then we're going to divide everything through by 25. So 1,000 divided by 25 leaves us 40 in the numerator. So the profit maximizing output equals 40 divided by n. You can see here as the number of firms increases, the amount of output any individual firm produces will fall. The profit maximizing price, we have our inverse demand. We're going to plug in for Q, 40 divided by n. So we're going to make a substitution in here for Q. And then we're going to just simplify this. So we're going to get 1,000 divided by n minus 400 divided by n, which just leaves us 600 divided by n. Here again, you can see as the number of firms increases, the price that any individual firm charges for lawn cutting will fall. The next thing I want to do with this problem is to find how many lawn cutting firms are there in long-run equilibrium. So the key thing about monopolistic competition, just like perfect competition, is that economic profit is zero in the long run. Firms just make a normal rate of return. So for economic profit to equal zero, that will occur when price equals average total cost. The price per unit equals the cost per unit. The firm will be making zero economic profit. The price we found in the last slide, 600 divided by n. And on the first slide, we found average total cost. So setting those two equations equal to one another. The next step is to substitute out this Q. We found that profit maximizing output for any individual firm is 40 divided by n. So where I have a Q on the right-hand side, I'm now going to replace that with 40 divided by n. So we get this step right here. And now just simplifying. The first thing I do is I take this 2.5 and multiply it by 40 to get 100. The next thing I'm going to do is I'm going to multiply this first term on the right-hand side. I'm going to multiply the numerator and denominator by n. So multiplying the denominator by n, the n's will cancel down below, and that'll move the n to the numerator. And then 200 divided by 40 is 5. So we get this result. And now let's move this 100 divided by n over to the left-hand side. And the left-hand side will simplify down to 500 divided by n. And then let's divide through by 5. So 500 divided by 5 is 100. And then let's multiply everything through by n. We've got to move to a new screen. So multiplying everything through by n, got n times n, we'll have n squared equals 100. Raising both sides to the 1/2 power to get rid of this n squared. We'll get n equals 10. So in the long-run equilibrium, when firms are making zero economic profit, that'll occur when we have 10 firms in the market. Each one of these 10 firms will be producing 4 units of output, 40 divided by 10. And the price that these firms will be charging is $60. All right, that's it. I hope you found this video helpful.